Class, in this video we continue our discussion in section 6.2 in your note packet on integration by substitution, which we also call the U substitution method. And so we are on page 78, and we're going to work the three examples on page 78 following the steps from the previous page on page 77. The steps are listed up here in the rectangle for your benefit, right? It's just a repeat of the steps from the previous page. All right, so in the first example, we got to find the antiderivative of 2x times x squared minus 3 to the 5th power with respect to x. Well, if you'll notice inside the parentheses here, x squared minus 3, if you differentiate that, the derivative of x squared is 2x, and the derivative of minus 3, the constant is 0. So the derivative, what's inside parentheses, is 2x, and we have the 2x right here in the integrand. So u equal to x squared minus 3 is a good candidate in using the u substitution method. So over here on the left, I have set u equal to x squared minus 3. And so the derivative of u with respect to x, right, is equal to 2x, right? Derivative of the right-hand side is just 2x. And now we have to isolate du on the left. So we multiply both sides by dx. The dx's cancel, and we're left with du is equal to 2x dx. So up here inside the integrand, right, we have 2x times x squared minus 3 to the 5th. So I can reverse the order of multiplication and put the x squared minus 3 to the 5th first, then times 2x dx. And now when I do my substitution, right, I replace x squared minus 3 with u. And so x squared minus 3 to the 5th becomes u to the 5th. And 2x dx is equal to du. And so I replace 2x dx with du. And now I have transformed this antiderivative in terms of x into an antiderivative in terms of the variable u. You'll notice there's not an x anywhere. There can't be an x anywhere. Where the antiderivative u to the 5th with respect to u, right, by the power rule of antidifferentiation, is equal to 1/6 times u to the 6th plus the unknown constant c. And now that I have this, the antiderivative in terms of u, I do a reverse substitution and replace u with x squared minus 3, right? Because we replace x squared minus 3 with u at the beginning of the problem. And when I replace u with x squared minus 3, right, the antiderivative of our original function is 1/6 times x squared minus 3 to the 6th power plus c. So this is the final answer to our original problem. In example 2, we've got to find the antiderivative of x to the 4th minus 3x squared plus 1 cubed times 4x cubed minus 6x with respect to x. So this is a big function. We've got to find the antiderivative with respect to x. Well, if you look closely, what's inside parentheses here, right, the derivative 4x cubed, or excuse me, the derivative of x to the 4th is 4x cubed, and the derivative minus 6x, and the derivative minus 3x squared is minus 6x, and the derivative constant is 0. So the derivative of what's inside parentheses here is what's inside parentheses here. So u set u equal to what's inside parentheses here, x to the 4th minus 3x squared plus 1 is a good candidate for the u substitution method. And so I do that right here. And so when we differentiate u with respect to x, right, derivative of the right-hand side is 4x cubed minus 6x. Now we got to isolate the du on the left-hand side. So we multiply both sides by dx. The dx is canceled on the left-hand side, and we're left with du on the left is equal to 4x cubed minus 6x dx. So what's inside parentheses is equal to u. So this raised to the 3rd power is equal to u cubed. And then 4x cubed minus 6x dx is equal to du. So I replace that with du, and now I have the antiderivative of u cubed with respect to u. So we went from an antiderivative in terms of x to an antiderivative in terms of u, and again, there's no x's to be found anywhere. There can't be an x anywhere. Well, the antiderivative u cubed with respect to u, using the power rule of antidifferentiation, is 1/4 times u to the fourth, and then we add the arbitrary constant c, and then we need the antiderivative in terms of x. So the last step is to replace u with what it's equal to. Well, we set u equal to x to the fourth minus 3x squared plus 1, so we replace u with that, and then this is our final answer. The antiderivative of this function right here is equal to 1/4 times x to the fourth minus 3x squared plus 1 to the fourth plus c. This is the final answer. All right. In example 3, we got to find the antiderivative of 8x over 4x squared plus 5 quantity squared. Well, if you look what's inside parentheses here, 4x squared plus 5, you'll note that the derivative of 4x squared is 8x, and the derivative plus 5 is 0, right? It's a constant. So the derivative, what's inside parentheses here, is equal to 8x. So that would suggest that u equals 4x squared plus 5, right, is a good substitution for this problem. If we set u equal to 4x squared plus 5, then du over dx, the derivative of u with respect to x, is 8x, and then we got to isolate du on both sides, on the left-hand side. So we multiply both sides by dx, and we get du is equal to 8x dx. Now, this fraction here can be written as a product of two fractions, 1 over 4x squared plus 5 quantity squared times 8x over 1. But 8x over 1 just simplifies to 8x. So, when we do our substitution, we replace 4x squared plus 5 with u, and we, instead of 1, and so when we do that, we end up with 1 over u squared, and then this 8x dx is equal to du. So we've gone from a problem in terms of x, an antiderivative in terms of x, to an antiderivative in terms of u. Again, there are no x's anywhere. There can't be an x anywhere. Well, to find this antiderivative, you know that 1 over u squared is the same as u to the minus 2 power. Remember, the minus sign in the exponent means reciprocal, so u to the minus 2 is the same as 1 over u to the plus 2. And now, using the power rule of antidifferentiation, right, we add 1 to the exponent, get negative 1, and then divide by negative 1, which is equal to the negative of u to the minus 1 power. Then we add the arbitrary constant c. Well, u to the minus 1 is the same as 1 over u. Remember, minus sign in the exponent means reciprocal. So u to the minus 1 is 1 over u to the plus 1. So we have the negative of 1 over u plus c. And now we replace u with what it's equal to. It's equal to 4x squared plus 5. And so this is equal to the negative of 1 over 4x squared plus 5 plus the arbitrary constant c. So the antiderivative of this function is equal to the negative of 1 over 4x squared plus 5 plus the arbitrary constant c. This is the final answer.